So hello everyone, my name is Steven and I'm going to introduce you our group's topic, infinity. So in the late 19th century, the mathematicians start to confusing about what infinity is and they want to look more deeply in it. A tool that they found to describe what infinity is set theory, uh, introduced by Cantor. This theory makes the mathematicians have a more abstract way to understand what math is. So, for example, what is set theory? When we look into it, this is a set, what is the natural number, 0, 1, 2, 3, and so on. So, thinking it more simply, it could be a circle that contains this kind of elements, which is 0, 1, 2, 3, 4, and so on, etc. They can be drawn in a picture like this. So, when thinking about, we're thinking deeper, we can find there might be a set T, like let's say there's a set T, where T contains all the set that contains more than one element. So T can be written as T1, T2, T3, T4, and so on, where T1 is a set that contains more than one element, T2 is also, T3 is also, and so on. So this set T also has more than one element because it got infinite elements. So T is also contains itself. So we can see there's a T in the circle, which means T is a set that contains itself exactly. With this kind of idea, let's go a step more deeper. So we can divide all the numbers, all the stuff into two sets, which is A set that contains itself, and B set that doesn't contain itself. For A set that does contain itself, we got T, like just I said, and for set that doesn't contain itself, we got N. The natural numbers are the real numbers, and so on. So as both A and B are sets, so we can look into where should B goes. For example, if B goes to B, it conflicts with the idea because it is said that B set doesn't contain self, but B contains. But what if B goes to the A side? It said A gives definition of set that must contain itself, but B obviously doesn't contain itself because it's not over here. So this is what we call Russell's paradox. It's introduced by Russell, obviously, and it shows that the sets cannot be defined arbitrarily and must have strict rules to understand these kind of sets. So this directly makes the mathematicians review all the set theories and systems to have more stricter rules to understand that theory. For example, Zeromelo Franco set theory, which will be introduced by my teammates later.